Witness the power that changes our world. Welcome to the El Niño season.
Welcome to your dose of wowness. Right off the coast of Peru, way down in the Pacific Ocean, the water is supposed to be cold. And I don't mean cold in the way the North Atlantic is cold during winter. It's cold in this highly specific biological kind of way. Basically, it's cold because deep, freezing water is constantly being pushed up from the ocean floor by the wind. And this one highly localized mechanism, well, it actually sets the stage for a massive planetary phenomenon that you've definitely heard of. But honestly, you've probably never seen broken down quite like this.
We call that cold water the Humboldt's current upwelling. And what it does is bring a staggering amount of nutrients right up to the ocean's surface. Under normal, everyday conditions, it sustains literally one of the richest, most productive fisheries on the entire planet. We're talking millions upon millions of tons of anchovies. It's enough fish to feed endless flocks of seabirds, enough to sustain an entire national economy down in South America. And, crazily enough, as we'll explore in just a minute, it's even enough to dictate the price of animal feed, thousands of miles away in places like Iowa. But here's the catch. Every few years, this highly productive, nutrient-rich cold water simply vanishes.
Out of nowhere, warm water moves in from the west. That deep, life-giving upwelling shuts down completely, and all those anchovies, they go right along with it. Back in the 19th century, the local Peruvian fishermen noticed this and named this unwelcome warm current El Niño, which translates to the boy child or the Christ child. They actually gave it this beautifully innocent name because the warm waters always seemed to arrive right around Christmas time. But let me tell you, to them, it was anything but innocent. When El Niño came, it meant absolute total devastation. For their nets, their livelihoods were just ruined. And what those fishermen couldn't have possibly realized at the time was that this warm water stealing their catch, it was really just the surface expression of something operating at a completely different, almost unimaginable planetary scale. Just to put the sheer scale of this disruption into perspective, let's look at the 1972 to 73 El Niño event. During that single season, the Peruvian anchovy catch completely collapsed. It plummeted from around 12 million tons down to under 2 million tons. The local seabirds literally starved. And because those tiny anchovies were actually a vital global source of animal feed, that sudden shortage instantly tripled the price of soybeans all the way up in the United States. It's all connected, right? The whole global chain, all of it driven by this one patch of warm water shifting off the coast of Peru. That is El Niño. But before we get into what El Niño does to the rest of the globe, we really need to understand what the normal Pacific looks like, because El Niño is a deviation from a baseline. And honestly, the baseline is almost as mind-blowing as the deviation itself. There's this circulation pattern in the atmosphere right above the tropical Pacific that has been running on repeat for thousands of years. It actually has a name. It was discovered by a mathematician who was just trying to predict Indian famines, of all things. And once you understand how this atmospheric engine works, El Niño's massive global reach stops being mysterious and becomes, well, almost inevitable. Okay, let's dive into this. We call this normal atmospheric engine the Walker circulation. Now, to picture how it works, you just need to hold three facts in your head at the exact same time. First, the trade winds blow west. Second, the warm water is in the west. And third, the warm water is in the west because the trade winds blew it there. So you end up with this massive temperature contrast between the east and the west. Over in the western Pacific warm pool, near Indonesia, the water is an incredibly hot 29 to 30 degrees Celsius. But way over in the eastern Pacific off Peru, it's kept at a chilly 20 to 24 degrees by that deep upwelling we just talked about. And this exact temperature difference is what actually drives those powerful trade winds from east to west. They literally act like a giant plow, pushing warm surface water across the entire ocean and piling it up in the western Pacific. And as that water piles up, it forces the thermocline, that crucial boundary layer separating the warm surface water from the freezing deep water, to physically shift. It gets pushed way deep down in the west and gets pulled right up toward the surface in the east. So all that warm water piled up in the west starts heating the air directly above it. This creates these towering, massive convective storm clouds and dumps heavy rainfall over places like Indonesia. Then that air flows all the way back east at a super high altitude, cools down, and drops back toward the ocean over the really dry eastern Pacific. But when an El Niño strikes, this entire beautifully balanced circulation just breaks down. For reasons that usually start with really slight atmospheric disturbances, those strong trade winds begin to weaken. Suddenly, they just aren't pushing as hard. And all that warm water that had been perfectly piled up in the western Pacific, it begins to slosh right back toward the east.
it actually travels in the form of downwelling Kelvin waves. These are massive underwater waves moving at an astonishing 2 to 3 meters per second straight across the equator. Now, what's really interesting about this eastward shift is how it creates this massive self-amplifying planetary cycle. As those Kelvin waves travel east, they push that eastern thermocline much, much deeper, which completely suppresses that cold upwelling off Peru. And here is the exact feedback loop that turns a tiny warming anomaly into a planetary event. A scientist named Jacob Bjerknes actually worked this all out back in 1969 using old ocean survey data. When he published his findings, it literally explained something that had been puzzling climate scientists for 40 years. You see, the loop feeds itself. Warmer eastern water reduces the temperature contrast that drives the winds in the first place. Weaker winds mean even more warm water flows east. More warm water in the east further weakens the winds. It's a relentless cycle where every single step makes the next step even bigger. So if you want to understand why El Niño lasts for way more than a few weeks, you have to understand why it basically cannot stop once it gets started. As this absolutely massive pool of warm water spreads eastward, it drags the entire migrating center of atmospheric convection right along with it. The rising air, the massive thunderstorms, the torrential rainfall, all of it just packs up and migrates east. And this has an immediate devastating consequence on the complete opposite side of the world. Regions that normally rely on the Western Pacific's heavy rainfall suddenly find themselves trapped under incredibly dry, sinking air. The Indian summer monsoon just weakens, predictably starving South Asia of rain. Actually, a British mathematician named Gilbert Walker first identified this atmospheric pressure seesaw back in the 1920s. He started looking into it after a catastrophic failure of the Indian monsoon in 1899 caused this widespread, horrific famine. He mathematically proved the connection long before we ever had the actual ocean data to explain how the mechanics worked. But as India dries out, the exact opposite happens on the other side of the ocean. The normally bone-dry eastern Pacific and the west coast of South America are suddenly sitting right underneath that migrating center of huge atmospheric storms. The hyper-arid Atacama Desert, which, by the way, is literally one of the driest places on planet Earth, along with the Peruvian coastline, are suddenly pummeled by intense, non-stop torrential rains. We're talking catastrophic flash floods and giant mudslides hitting landscapes that have absolutely zero natural or human infrastructure to handle that kind of water. And this brilliantly illustrates the concept of teleconnections. The effects of El Niño absolutely do not stay in the tropics. They ripple outward, affecting the entire globe through these large-scale undulations in the upper atmosphere called Rossby waves. Basically, these waves completely reroute the jet streams. Storm tracks change completely. For places like Australia and Indonesia, this means severe, punishing drought. The Australian interior dries out entirely, and the risk of massive bushfires absolutely skyrockets. This incredible mechanism, this one planetary engine that everything else depends on, is the absolute foundation for understanding the weather patterns that change the world. And actually, we are exploring this concept over 5 explainers this week. If you've been here since day 91, welcome to the second arc. But if this is your very first explainer with us, you should know our recent Human Origins arc is a fantastic journey and totally worth going back for. So, putting it all together, we had Gilbert Walker's statistics in the 20s, and then Jacob Bjerknes gave us the physical mechanism in 1969. But there was still a huge gap. In 1982, the absolute strongest El Niño of the 20th century hit its peak, and basically, most forecast agencies didn't even realize it had started. Think about that. Scientists had understood the actual mechanism for over a decade. They had the theory down perfectly. But what they did not have was the hard data. They lacked the real-time ocean measurements that would have clearly shown the warming building up months in advance. To make matters worse, early satellite data had actually been contaminated by the eruption of the El Chichon volcano, which completely masked the warming ocean. The resulting surprise of that 1982 El Niño ended up costing thousands of lives and around $13 billion. But what happened next is honestly one of the most consequential investments in climate monitoring ever made. The global community banded together and deployed the TEO/Triton array, which is a massive network of 70 moored buoys stationed all across the tropical Pacific. This single action transformed El Niño from theoretical science into hard, real-time predictive forecasting. So, when the massive 1997 El Niño finally arrived, we didn't get blindsided. We saw it coming a full 6 months in advance. The Walker circulation has been running like clockwork for millennia. But here's the thing. If the background climate state changes, this entire cycle changes right along with it. The deadliest El Niño in the modern record didn't actually happen recently. It happened way back in 1877, and it killed an estimated 50 million people through simultaneous harvest failures across 3 different continents.
And the reason all of this matters so much right now is that forecasters are actively watching the Pacific today, monitoring new warming anomalies with that exact same level of concern. The elegance of this planetary machine is almost offensive when you think about it. The difference between global stability and the failure of harvests that kill millions, it all comes down to whether the wind blows a little harder or a little softer over a patch of ocean the size of a continent. So what happens to our modern, highly interconnected world if this ancient machine permanently shifts into overdrive? Here's what El Niño actually is. Day 97. See you there.